I am still doing my compiler for a simple imperative programming language called Elna, and I'm trying to fix a bug in records. So we have a simple record data structure, and the records now can only have simple fields. So the type of the field can be only a word, a primitive for byte type. And actually the parser can already parse other types as field types, for example enumeration. And enumerations have the same size, so each enumeration value is also 4 bytes, so it should actually just work if I, for example, replace this word with its real type, L03 kind. In this case, but it doesn't work. The compiler crashes for some reason. So word currently is just a placeholder. It is a generic type because we do not have real type checker yet. We will start to look for the reason for this bug with a simple example. So we just go to the end of type definitions, and we define a new enumeration type. Let us call it some enum with 3 values being 1, 2, and 3. This should compile. And we define a record that uses this enumeration. The record is called R, and this is record. It has 1 field. Let us give it a unique name so that we can find it easily. For example, I do not have fields that are called ASDF, and we say that this field is of type some enum, and we finish the record. And it still compiles. But if I define a procedure then, and I say that this procedure takes a pointer to this type, this will probably still compile. But if I dereference this pointer and try to access this field and assign to some value to it, then it crashes. So there is some problem with the assignment. Let us try some other case. So we define a variable x of some type, and we try to assign ASDF to this variable. Then we can see whether the error, so there is some problem with accessing the field, not in the assignment, but in the field access expression. I would like to define more fields and make it this field word, or let us call it before, and let us define a field after this enum field and call it after, and see that this whether this changes something. Yeah, and I want to check whether I can access other fields. For example, before. Yes, I can access the field before the enum field. And I can access the field after the enum field. That is pretty interesting. We can actually just say return, then we do not need any variables. So do we generate any code here? No. So the file that should contain the assembly output is empty. Field access expression is the expression we are interested in. This is the parsing function. The parsing is probably not the reason for the crash. So this is the type checking. Type designator. This one actually can be interesting. So this is a designator and we check the expression type. And then we get the type of the expression, save it in the expression type and check whether it is enumeration. Or record access. So this is field access expression. A field access expression has type declaration aggregate, word field and length. We can try to print the type field access expression aggregate. Let us add a debug statement here. So we just print a comment into the assembly. And as the comment we print the field name, since it is just a string, so it is field access expression field, and field access expression length is the name length. And if we compile this thing and we then go into the assembly, it would be, we'll put stage 18 CL, the file is still empty. And if I flush the output stream, we still do not have any output. Oh, this is actually the wrong place for that, because we compile this stage with the previous stage. So we actually should go to the previous stage, and this is the LNTAC designator function. We go to the 17th stage, LNTAC designator, and we put this printf statement here. The argument order is of course wrong. Now we have some output. And here we will have also this ASDF field at the end because it is the last function, and we can check whether we select the right branch, and we put just this printf in the if block and put a 1 here, and also in the else branch I put 2 here. Then we can compile it again. So it selects actually the wrong branch because ASDF is not enumeration. It is the field itself is the enumeration, but this this field access expression is actually a record field access and not enumeration field access. Okay. The type is set in the type checker. Type if statement. Type field access. So I want to look at this printf statement once again. So actually we just read the type from the field access expression. So we should just find the place where this type decoration is set, and it should be somewhere in the type checker. And here we have a comment that we check here whether it is an enumeration or a record field access. And I visit here a field access expression. So variable expression is what? L03 variable expression. And we assign aggregate to this. Aggregate is the left size of the field access expression, and we get its name, but in that case we won't have a variable expression. So this one should be false. In our case, the base type is still nil. This is record field access. This actually makes sense. So we have this field access and record. The type of the whole expression is the type of the field we accessing, and the type of the field is enumeration. So the type of the whole expression is enumeration. This is actually fine. But the base type, so the aggregate type, the type on the left side is a record. once again, we check the type of the whole expression. Which is wrong. We do not need the type of the whole expression, but only the type on the left side. Where do I use this designator base variable? I use it here, but which stage it is? It is stage 17. Let us set it outside of the if. And we have also this aggregate type variable. I probably use it directly afterwards. So we can also assign it. And the thing that I actually want to check is not the expression type, but the aggregate type. This is stage. Let us see if we can compile it without this procedure. Probably we cannot. It crashes right away. So we get the expression type, I get the aggregate. And I get the designator base. If I put it here again, then it should compile eventually. I still should be able to get the designator base. But should have removed it. Okay, but if I move this statement, this assignment, then it won't compile anymore. Okay, it compiles, but if I replace this expression type with the aggregate type, it won't compile. The problem that the thing on the left side, if it is an enumeration, then this is not an expression, but it is just a type name, and I probably do not save any type name with that. I wonder how do I handle it. This was type filter expression. So once again, if it is a variable expression, so if this is just a name and not an expression, when we do a lookup, and if the lookup is successful, and what we found, if it is a type, then this is an enumeration. That means that we do not assign anything to the base type. What will it be at all? So I say that parser node type decoration is base type. This is the type of the whole expression. This is fine. Where do I set type decoration? Here. We can actually do the same. So just check whether it is a variable expression. This one will probably set the type. So I pass the aggregate here to this type designator, and it will set the type of the designator. but for variable expression it will be probably be just nil. No, this is wrong. It's aggregate. If aggregate type as whole is nil. Okay, that works so far. And then we go back to the stage and uncomment this function. Yes, that looks much better. The problem that I have that I cannot compile the 18th stage with itself, but it is actually fine since we haven't ported these changes to the 18th stage, so we just have to do the same port these changes to the next stage. We can actually remove these debug statements then, and I think that the only function that I changed was this lnotac designator. So what I did, I just moved this assignment and I moved this assignment. Then I checked whether the aggregate type is nil, which means that the expression on the left side is not an expression but a type name. Nil. So I really should just copy this thing. Yeah, that compiles now completely. And the final test, we can actually go to the stage 17 once again and add a comment that we support enumerations as record field type, and now we can go to this kind and write lno3 kind here. And it compiles. Very nice. So we can remove this test function at the end, and let us go through type definitions and add the real type to more types. Actually, all these kind of expressions are tree kind, because the types extend each other. So we can replace this with tree kind. And I actually had a test type at the end. We should remove it. So somewhere at the end we have these two test types. We can remove them now. And go back and set the tree kind for all the expressions here. So these literals are expressions as well. We can replace that all. So expression. And just compile everything after some changes, just to be sure that we haven't broken anything. So we still have a few expressions. Yeah, tree kind and tree kind. So statements are also abstract syntax tree nodes, so they will have their kind is listed in this enumeration as well. Okay. expression add tree kind, and then we have conditional statements. It is just a helper type. Then we have declarations. Declarations are tree nodes as well, so they will have the same kinds. There shouldn't be that much declarations, I think, so we have type declarations and we have variable declarations. Then the types are not tree nodes anymore. So that was everything, I think. Symbols, other enumerations. Yes, that was everything for the tree node. What do we have else? then there are these ELNA type records. They should have also some enumeration that gives their name, their kind, ELNA type kind and symbol info kind. These two enumerations go in here. We can just insert them here and probably write a comment that this is the type representation. And then ELNA type is just a generic type, so this is the base type of all other types. And they all have this ELNA type kind. ELNA type kind. Does it compile? Yes, it does. So then we have symbol info, and symbol info lists the type of symbols that are supported in the symbol table, and these are this ELNA symbol info kind. So we can also replace, this is the generic type, ELNA symbol info kind. I hope it's correct. Okay. ELNA symbol info kind, and here ELNA symbol kind, and here. So that was it. And I have an error somewhere. Okay. We do not have the types for the errors yet, but we have some enumerations for the tokenizer. TAC operator. Yeah, I think that was it. I had some types at the beginning, so we have ELNA instruction list. Model ELNA instruction declaration. Yes, that was it. So let us exit. I want to compare the stages to see whether I forgot to port some changes. I think actually not, but if I look what I changed in the 17th stage, then I just added this comment, that's fine. Then I removed a debug statement and I just move these assignments. That actually looks fine. And the 18th stage will contain all these changes in the types. Here I removed this as well and did the same changes here, and these are some unrelated changes, so that's fine as well. I have a few more minutes, and I want to make a small change to the build system as well. So I switch from pure rake to the rake with the Ninja build, but I still need some rake tasks to do some final checks. For example, the rake task will compare, will do the final validation and compare the compiler output. So basically, if I execute, so this seems actually to work. Let us look into the rake file, and the rake file has a dependency on the compiler from the last stage and assembly file from the last stage. Actually, the compiler is compiled after the assembly, so if the compiler is there, then the assembly file should be also there. It probably shouldn't be provided explicitly. And what I actually want, I have a task that generates this build Ninja file, but I also want a task that generates this compiler file. So we define a task. This is a file task actually, and we put it with the other file tasks. This is actually a file task, and the file is build valid stages last. Compile. Its dependency is actually the Ninja file, so we can say that it is build Ninja, and then we get this. I actually do not need that task itself, because I want to just execute Ninja F. Oh, I need the task. It was task prerequisites, wasn't it? Oh, I will never write it correctly. Yeah. So, and we just get the first dependency. That should compile the stage, and then we can use this stage. I probably shouldn't depend on this assembly file. So I get the prerequisites and group them by extension. What happens if I do rake? So, but if I remove the assembly file from the list, it will probably fail. Exactly. Let us actually just print what is in this grouped map. Oh, closed too early. So we have 3 values here: assembly file, the source file, and the compiler file. If the assembly isn't there, Rec will probably have the problem to identify the task because it will not know how to generate the assembly file. We can test it with rake clean and just try to execute now right away. Yes, it doesn't know how to create the assembly file. So the easy solution would be just to remove this file from the list and just append this extension to the binary name, basically plus period s, and that's it. So it calls Ninja first. Yeah, looks fine, so we can remove this again. Actually, I do not really need group by. Get source diff expected and pipeline from file. And diff arguments. But at least we have a task which can do the final validation. So it compiles the last stage once again and compares its output with its with the output of the same compiler, but compiled with a bootstrap compiler. I think that's fine. I think this one can be a bit simplified. So I pass expected. No, I actually should run exe. Yes, I execute first. I execute first my compiler. Pass the source code to it. No, it is fine as it is. Okay. That's fine as it is. So now we have also a task that can do the final validation as we had before we switched to the Ninja for building the compiler itself. And also we fixed a serious bug where we couldn't use enumeration as type for record fields because the field access expression was broken. It was wrongly typed by the type checker. It took some time, but yeah, some bugs are unfortunately difficult to find, and we will continue next time, I would say.